Factoring a polynomial by grouping. We have three expressions here, okay? Each of these have four terms. So this one, the first term is 6m cubed. Next term is 3m squared. Next term is the opposite of 4m. And the fourth term here is the opposite of 2. This one has four terms as well, okay? And this one also has four terms. Now the first rule in factoring is look for the greatest common factor. Unfortunately, the greatest common factor between these four terms is just 1. So that's not very useful. So we're going to resort to another technique. And this technique usually works with the GCF of 1, and then there's four terms. And the goal now is to group these in such a way that maybe we could actually find a common factor that's not just 1. So why don't we get started? First thing we're going to do is group these first two and find the GCF between those two terms right there. So the GCF between those two terms is 3m squared. And then we're going to use the distributive property. So 3m squared, distribute to something, has to get me 6m cubed. That means I have to have a 2m. We need a plus sign, right? We're going to distribute 3m squared to something that will get me 3m squared. Well, that something has to be 1. Now, we're going to try to group the second two terms. What do these two terms have in common? Negative 4m and a negative 2. Well, they have a negative 2 in common. So let's write subtract 2. And let's see what's left. We're going to have 2m here plus 1. And you could always check with the distributive property. Now, what do these two terms have in common? Why don't I change the coloring scheme here? Now, what do they have in common? They clearly have a factor called 2m plus 1. Sort of magical. Remember, the first greatest common factor you found in this problem was 1. Now you actually see a common factor of 2m plus 1. And then what's left? What we have left is 3m squared minus 2. So how many factors do we have for this expression? We have two factors. The first one is 2m plus 1. The second factor is 3m squared minus 2. You could always check by multiplying. So feel free to multiply that. Let's circle our answer there. Okay. Now, if you're really having trouble seeing this, I could explain this a little bit differently. So what if you had this? What if you had 3m squared times p minus 2 times p. What do these two terms have in common? They have a p. And then what's left? 3m squared minus 2. Once again, you're still using the distributive property. But what do you think p was? P was just a name. P was the name for parentheses 2m plus 1. So if we go back, now we could put the name back, 2m plus 1. And we still have 3m squared minus 2. Notice we get back to the same spot. We still have exactly two factors. Let's try the next one. Let's group the first two terms. And then we'll group the second two terms? What's the GCF of the first two terms? Well, they have a 4, and it's going to be 4x to the fourth. So why don't we have 4x to the fourth, and let's figure out what's left. We have 5x squared using the distributive property. Using the distributive property again, we have minus 7, parenthesis. What do the second two terms have in common? We have subtract 15 and 21. They have a 3 in common. And then what's left? Be 5x squared minus 7. Wow, I don't think that was a coincidence. Now, what do you have in common? You have 5x minus 7 as a common factor. And then what is left? It's multiplied to 4x to the fourth minus 3. So, this expression, once again, has two factors. Last one. Similar idea. Group the first one. Group the second one. Why don't we work a little bit faster? X times the quantity w minus 7. Once again, check with the distributive property. Now we have what? What do these two terms have in common? How about a negative 7? And then what do we have left? W. It's got to be what? A negative times a negative will get you a positive, so it's got to be w minus 7. What do these terms have in common? They have a w minus 7 in common, and then your last factor is x minus 7. Once again, you have two factors here. And that is factor by grouping.